have to draw our Lewis structures a little bit differently.
Makes sense.
Right. So previously we had one of them losing, one of them gaining.
Right.
For a covalent, we have to make sure that they actually are sharing. So let's go ahead and do H2O first, because everybody knows water, right? So first I'm going to consider I have two H's and an O, right?
Right.
How many H's, how many dots does the H get?
It's column 1, so it's only going to have one dot.
Exactly. One valence electron, one dot. What about this H?
Same thing.
Same thing, one dot. How many does oxygen get?
Let's see. It's in 16, so it's going to have 6 around it. 6 valence electrons.
Exactly. And do we remember how we put our dots around?
Yeah, we start in one spot and we draw them like a compass. So we go around
2, 3, 4,
and yeah, we gotta
5,
keep
6,
going.
right?
Right.
Oh, that's it. I'm done.
Right.
All right. So once I have my basics down, I can put these together. Okay. My oxygen has its 6. And these two lone electrons are the ones that actually need a partner.
Okay.
So I'm going to take this H and I'm going to stick it here so that it has a partner. And this one's going to go here so that they have a partner. Okay? So these are going to form a bond. Okay? The lines represent a bond. They mean that there are 2 electrons in it. Total needs to add up to 8 while sharing. And if you look at what the oxygen now has, it gets all 8 of those electrons.
So you can count, we can pretend that we're going to count those. So 1, 2, 3, 4, 5, 6, 7, 8.
Exactly. So
Okay.
now our oxygen is 8. Okay. This is where it gets a little bit confusing because these go with the hydrogens, but how many does that make for hydrogen?
2.
Right, it only makes 2. So we're not actually making 8 for hydrogen because if you remember our Bohr models, the lowest level is full at 2.
Right.
And that's all that hydrogen has. So actually
Okay.
all hydrogen needs is 2. It's not going to actually need 8. But they get those 2 as well. So this is how your covalent bonding works.
Woohoo!
Go. All right, so I'm going to go ahead and let you do CH4.
All right. All right. So you started off, we've got the 4 hydrogens and carbon.
Right.
And hydrogen has only got 1 dot. We just did that one. So we can put a dot on each one of those. And then carbon is in group 14.
Yep.
So that means it's going to have 4. So I need to go around 1, 2, 3, 4, like that.
4 dots.
Now, here's the basics so I can put them together. So I've got carbon with the 4, and I can put the hydrogens with the lone pairs you said.
Exactly, because these guys
Okay.
are lonely.
Aw, well come here, hydrogen. There we go.
Aww.
So I can go like this.
Yep.
And then with the water, we can count. So we can count all of those together. So carbon thinks it's got 8.
Yep. 1, 2, 3, 4, 5, 6, 7, 8.
And then each hydrogen thinks it has 2. And we just talked about how hydrogen only needs 2.
Exactly.
So everybody's happy.
Everybody's happy. And if you want to actually connect your dots and make a line, that forms a bond. You don't have to. You can leave them as dots.
I want to connect them.
But you can connect them and make a line. And we do need to understand that a line does mean that there are 2 dots in it. So even if you can't see the dots, you just see a line, that means that there are 2 dots in the line. Okay? So let's try NH3.
Yes.
I have N and 3 H's. How many does N have?
5.
1, 2, 3, 4, 5. Okay? So, can we already kind of see where those H's are going to go?
I'm guessing they're probably going to go with these lonely ones.
Yes, we got lonely ones. They don't want to be lonely anymore. We should make a song. And that's what an H3 is going to look like.
That's pretty easy.
Pretty straightforward, okay? These little bonds here, because there's only one line, they're called single bonds, okay? Because they are making a single bond. All right, so now I'm going to show you one that actually has a double bond. What does that mean? Okay, so we're going to try O2. O2 is, we're going to have, how many does oxygen have?
6.
1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right?
Okay.
All right, so if we're looking at our oxygen, we have our lonely ones here. So there's not going to be just one place for this oxygen to go. So instead, I'm just going to put it beside it. I'm going to count off the 6 again.
Okay.
1, 2, 3, 4, 5, 6. But that looks a little uncomfortable, right?
A little bit.
Okay, so I'm going to go ahead and I'm going to put this dot over here instead, just so that we look a little nicer.
Okay.
Okay? So these guys are side by side. We can form a bond, right?
Okay.
Make it prettier. So there's our bond. But what about these guys?
Well, they're still lonely.
They're still lonely. They don't have to be lonely. Let's put them together.
Oh, that's good.
So they're going to connect. Okay, but they're not actually going to connect down there like that. They're going to slide up here with this other one. And so we're going to have 2 bonds side by side.
Could that possibly be called, is that our double bond?
That is the double bond.
Huh.
So if we count this,
1, 2, 3, 4, 5, 6, 7, 8.
exactly, because each line
Okay.
counts as 2. And this one gets 8 as well. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so everybody's happy.